All right, so this is our fifth experiment, and what we're going to be looking at today is our percent composition. And we're specifically going to be looking at the percent composition in something that you've probably used before, and that's our fertilizer. Can you get our fertilizer? Now, one thing that you've probably noticed on fertilizer bag is most of the fertilizers that you get have these numbers on them. And if your parents have ever done any kind of growing of vegetables or flowers or farming, a lot of times they want specific numbers here. For instance, this one says 11, 15, 11. What this does is it gives us a percent. So that first 11 is the percent of nitrogen in it. The second number, the 15, that's the percent of phosphorus. And this last percent, that's 11, is the percent of potassium. Okay, you can put that down there. So what we're going to be doing is trying to determine that middle number today, the percent of phosphorus, and we're going to see if the bags are giving us the correct value. Because the thing is, when used to, the way that they did the numbers had to do with when the fertilizer was burned, how much of a gas that it gave off, and it dealt with a compound that isn't even really used in fertilizer at all. So when they started doing a different type of compound, they didn't really change the way that they did that. So it's not exactly perfectly correct. It's pretty good, but it's not exactly perfectly correct. So we're going to look at that and try to determine that. So to do that, we're going to use different types of fertilizer. Now, each group will be assigned a specific fertilizer. So everybody won't have the same exact fertilizer. Okay, different groups will have different ones. But regardless, most of the fertilizer is going to need to be in a more powdered form than what you have it in. So your lab says that you need about a gram, I do believe. Yep. So what you want to do is just put a little bit of fertilizer. You don't have to pour any in it right now. But you're going to use something that we are going to grind it up with. So show us what we're going to use. All right, what's that called? A mortar and a grinder. Well, that's close. A mortar and a pestle. But you use the pestle to do what? Grind. And you're showing us very well right there how to do that. We put our fertilizer in there and we grind it up. Now, all right, you can let that down there. Now, the thing is about it is you're not going to be able to get every bit out of there. So just kind of pour some fertilizer in there, grind it up, then get the gram out of that. Don't get a gram and put it there because you're not going to have a gram out. And it's very, very important that you get the exact mass of the fertilizer that you use because you're doing a percent. So it's going to be very important that from the beginning, that you have an exact mass. So you need to know exactly how much you're starting with. So once you get your exact mass, be sure you put it in the data table. You're going to put that in your beaker. Now, you need to stir that really, really well. Different types of fertilizers have fillers in there that are not going to dissolve. So once you've stirred that really, really well for several minutes, you're going to need to suction filter that. Now, you used a Buchner funnel and suction filtration in lab 3, so you've already done that, so I'm not going to go through how to set up the Buchner funnel and all that because you've already done that before, okay? But one thing about this one that's a little different, normally we're needing what we catch on the filter paper. When we do it this time, we're trying to get out those fillers that don't dissolve. So what you need is the filtrate. In other words, when you do this first filtering, you need the liquid that comes through, okay? So you're going to need that liquid. So what's trapped on the solid, on the filter paper, the solid, you can just put that in the trash. Now, be sure it tells you to rinse it with small amounts of water. Don't do too much because, again, you are getting a too dilute solution. If you say, oh, the water here is not like cheese, okay? When you're cooking, if it says a cup of cheese, I'll put 2 cups in there because more cheese makes it better. Not true with this distilled water. If you put more in there, you're going to have a too dilute solution. So be sure that you just kind of rinse it really well. All right? Again, the filter paper with any particles you can dispose of, you want to keep the liquid, okay? So get that liquid out of your filter, put it back into the beaker. Anything, you do need to wash that beaker. You don't have to get every particle out of that beaker because any particle that's left in there is stuff we don't want anyway. But you do need to wash it really well and get all of that out before you add the filtrate back in, okay? Then you're gonna get your magnesium. That is in order to precipitate your phosphorus compound that's in there, okay? We added in excess so that we push the reaction to the product side. Then you're going to use an ammonium hydroxide solution. Now, you have to have a basic solution to get the precipitant, but you want to do that slowly. Notice in number 5 procedure, it says to add that slowly. You need to do that over the course of a minute. You and your partner need to work well. One needs to slowly pour while one continuously stirs. That will help you get better results. Once you get the 15 mils added, you don't get a good precipitant unless you have a basic solution. So you're going to test it. To test it, we're going to use red filter paper, red litmus paper, pardon me. You use red and blue litmus paper to test for basicity and acidity. Red paper you use to test for basicity. If red paper, stir it with the stirring rod, touch it to the paper. If it turns blue, it's basic, okay? If you have blue paper, you stir it, touch the stirring rod, if it turns red, it's acidic. Now, if blue stays blue or red stays red, it doesn't necessarily mean it's neutral. It means that just it's not basic or it's not acidic, okay? So you're going to use red paper, stir it. If you touch the paper and it does not turn blue, add another milliliter of the ammonium solution, stir it again, test it again. Add a milliliter at a time until the red paper turns blue, okay? Then, put the beaker to the side, let it sit for 10 minutes. Don't mess with it, just leave it alone. While you're waiting, your suction filtration apparatus that you've already used, wash it really good. Wash the Buchner funnel really well, wash your filter flask really well, get it ready because you're going to do a second filtration. This time you do want the precipitant. So this time we do want the precipitant. It's the filtrate we don't want, okay? So we're going to do a second suction filtration. Wet your filter paper with 70% isopropyl before you start. After that 10 minutes is done, you're ready to filter, okay? So with that suction on, you're going to pull that through. Once you've gotten it all out, and here you do need to get all the particles out of the beaker. So use the isopropyl alcohol and rinse out your beaker. You need every particle possible. Use a rubber policeman on the end of your stirring rod to help get it out of there. You need everything, because remember, we're getting a percentage of that precipitant. So anything you leave in the beaker, you're losing amounts of your solid, you're going to get a lesser percentage, okay? So be sure you do that. Rinse it with 70% isopropyl. Rinse the solid on the filter paper with that to be sure that you're getting any of that solvent out. Then let it pull for about, once you're done and you say, okay, I've gotten everything out I can get, let it pull for another 5 minutes to help it dry. Then you're going to put that onto a watch glass and let it dry under the heat lamp. You need to be sure it gets good and dry. Anything that if it's still wet, then you're going to get a percentage over that. If you get a percentage that's over 100%, a couple of things can happen. Either something's happened earlier, you didn't separate something out correctly, you let some of the particles from the first part into the filtrate, or it's not dry. So if you get a percent over 100, so again, do not get rid of your precipitant until you've done all your mathematical calculations. That's just a good rule of thumb for everything. Don't get rid of anything until you've done your calculations, because a lot of times there's things you can go back and kind of do. If you get over 100% yield when you do this, put it under the heat lamp again. It usually means it's not dry. Another thing that could affect it, you've got this glass. It has to be, once you put it under the heat lamp, you've got to let it get to room temp. Things like heat affect weight, okay? So if it is not room temperature, you're going to get an incorrect weight. So be sure that that watch glass and everything is very, very much gotten back to room temperature before you weigh it. So again, those are a couple of things if you get over 100% yield to go back, reweigh. Maybe you didn't let it get all the way to room temperature. If that doesn't work, put it back under the heat lamp. It usually means that it didn't dry well enough, okay? As far as disposal, really easy. That filtrate can go down the sink. Precipitate and filter paper can be discarded. So be sure. And it tells you there if your mass is more than 2 grams that you probably made a mistake there. So just kind of check that. Do the math before. So you're going to compare that to our phosphorus. Again, the bags of your fertilizer aren't exactly correct because of the way that they do it. They don't do it the same way they initially did, but they didn't change the numbers in. So that's why we're doing this, and we're going to find that percentage of phosphorus. So remember your percent composition equation when you're doing percent. Remember, it's just basically part over the whole times 100. Now that's any kind of percent. All that changes is what my part is and what my whole is, okay? You're also going to be looking at a percent error, okay? So for your percent error, the equation is there on that, so you need to do that. One thing with a percent error, you should never have a negative percent error. So be sure that on that top portion that you do an absolute value so that you don't have a negative percent error, okay? So it's true minus experimental over true times 100. So of course if that experimental is greater, you would have a negative, but we always take the absolute value so that we don't have a negative percent error. Okay? All right, and that is our fertilizer lab. So see you next time.